when we look at this, right, as James did correctly for us, you have those right processes, right? They may write the question as y dash, they may write it as f dash of x, they may write it as dy dx, either of those. I would always write it back as dy dx so that you are able to apply this idea of a separable differential equation, right? Which is the idea that we group x's and dy's together. And so when you do the algebraic rearrangement, you get 1 on y squared dy is equal to negative x dx. And be very careful here because although you can check your solutions to a differential equation, it's not as easy as a typical equation. So you want to make sure all these steps here are correct. Okay, now we can integrate both sides. I'll do that in a different color. And then we have, what was it, James? Negative 1 on y?
Yeah.
Yep, is equal to, Callum, what's the right-hand side here?
I don't know, I just crossed it all out and was redoing it.
Okay. If I'm just integrating this side over here.
X squared.
Yep. Yeah, perfect. Cool. There's your constant that we have. Remember, we can like merge both constants together. Now, at this point, hey, do we have to have y as a subject?
Yeah.
So, if the question asks you to find the general solution, typically that's what they want. They want this part as the subject over here, right? They want y is equal to the subject. So, I'm going to go ahead and do that. So, we've got, we can multiply both sides by y here.
Would it just be easier to bring the power of y to negative 1?
Yeah? And where do I go from there? Y is...
Then it's negative 1 root of both.
Okay, so if I have it like this... Yeah, I think so. So if I raise both sides to the power negative 1?
Yeah.
Yeah, sure. So I get y is equal to here, and this whole thing becomes negative 1. Is that what you're saying?
No, I don't mean like you can rewrite minus 1 over y as y to the negative y to the negative 1.
Oh, sorry, there should be a negatification there. Like that?
Yeah.
And multiply both sides by negative 1 here?
Yeah.
Yeah?
But I'm not that right, but the thing that comes my mind.
Sure. This is what you had?
And then I haven't gone anywhere because I don't know if you can do.
So, at this point, really, right, what you want to do to both sides to get rid of this negative 1 power is think about if they're both squared, right? What do you do to get rid of that square? You take the square root of both sides. So the same thing kind of happens here, right? How do I remove this negative 1? Right,
Negative 1 root?
Exactly right. That's exactly right. What is the negative 1 root, though? Like if you raise something to the power negative 1, it becomes 1 on x, right? So you're really taking the reciprocal of both sides here. We can do that. Before you do that, though, I typically want this as one fraction, though, because it's going to make it a bit smoother, right? So if I have this as one fraction, think about putting things under a common denominator. We've got x squared minus like 2c on 2, so you can put it under a common denominator in that way, yeah? And then now when you raise both sides to the negative 1, you're really just taking the reciprocal, right? So y is equal to 2 on x squared minus 2c. And like I said, typically in answers, this is the correct answer, right? But typically what they're going to do is they're going to rewrite this constant as like one letter, because it's a bit nicer when you're solving for the constant in a moment. This is the general solution, but if you want to solve it, you kind of just want to find one letter, right? So you can replace that with 2 on x squared minus k, right? So that can be your general solution for this. Yeah. Sorry? You could actually, you know what? You could do plus k, and that's fine too. When we change the signs for these constants, that doesn't really affect what you're looking for because it will just change what this k value is. So yeah, you're right, Matt. They actually typically like to have like the plus as the constant there. Okay, so that's the general solution for this differential equation here. Right. Now we had a particular solution. Yeah. Kyle, what were the conditions that they gave you for the particular solution? Yeah. So, well, how did they write it out? What? Yeah. Okay, now this is something you need to be very familiar with because this is, now we want to find a particular solution using these, what we call initial conditions, right? And there's some intuition here. Like when you used to see f of x is equal to something, this is kind of using the same idea. It's basically saying like y of x is equal to something, right? Okay, so it's using the same idea. And so this is why, if you really want to write it, just to be clear, when x is equal to 1, y is equal to half. That's basically what it's saying, right? So if we go back and we go to this equation over here, right? If I go to this equation over here, I can check if this actually works. So we've got substituting y is equal to half is equal to 2 over 1 squared plus k. All right, and then we try and rearrange for k here. What's the easiest way we could do this? We could multiply both sides by 2 maybe. So I'd get 1 is equal to 4 on 1 squared plus k. And then we can multiply both sides by this denominator, if you're okay with that. So 1 squared plus k is equal to 4. So k is just equal to 3. And that's not quite the answer. That's the constant, right? So don't just stop there. You've done all the hard work. Do the most important part, which is actually writing what we call the particular solution, which is this, which is y is equal to 2 on x squared plus k. Now, I briefly mentioned as James was doing this, like he'd done all the right steps, but he'd made just a really small error here.
It wasn't that. It was just a big
It's a small error in the scheme of the whole thing, which is such a shame because it's like you do all the right stuff and then just one little algebraic mistake can kind of cost you, okay? So my suggestion and tip is you have to be aware of what strategies there are to help you check if you make these algebraic mistakes, right? What you can do, this is a kind of like a time sensitive, are you gonna have time to do this? But there are options to check this, right? Remember, at the end of the day, you're finding a solution to this equation, right? So what is the solution that we're actually looking for? This is meant to be the solution. Does that make sense, right? Like this here is meant to be the solution to this. But this is y, and what's this? This is...
Oh, you take the derivative.
That's right. So what you can do, again, time sensitive, right? Because these aren't always easy expressions to take the derivatives. Wait, why did I write plus k here? It should be plus 3. No one's calling me out on this stuff. If you take the derivative for this one, right, and then what do you actually have to do to check if it satisfies? It's not just enough to take the derivative, right? You take the derivative of this, and that's meant to equal to what? Could you elaborate on that? If I take the derivative of this, what's this actually meant to be equal to? On the right-hand side. Negative x y squared. So it's meant to equal to negative x y squared. But what is y? Well, y is this equation over here, right? So you can see if you take the derivative of this, the way that you check is you say, okay, is the derivative of this equal to negative x, and what is y squared? Well, y squared would be this whole thing over here, right? So it's not always feasible to check that because, again, that's like a big expression. But if you think about it, in an exam, they're probably not going to ask more than, like a handful of DE questions. So you're not checking this every single time, yeah? It's just, you have to be aware of what actual options do you have in a situation where, hey, I've got a bit of time, can I actually check my answer? I guess another option is to just actually do the question again, but typically what I find is if I make a mistake once, I may make it again, just redoing the same question. So you want to be aware of different approaches that allow you to check your answers, right? Because in your agency, you kind of only have one shot at this.